Hello and welcome to the SAFI Learning Center. This short tutorial will show you how to associate a lateral distribution coefficient to a simple bridge in 2D. When the bridges are sufficiently simple to be modeled in 2D, we must associate a lateral distribution coefficient to the moving load. A lateral distribution coefficient represents the ratio of a truck that will be associated with the modeled beam in the 2D model. In the example below, the axle factors were initially specified manually. One factor is for the axial and shear force in the beam, and one factor is for the bending moments. Note that the fraction of truck applicable varies depending on the nature of the effort in the bridge. The value of the lateral distribution coefficient may be smaller or greater than 1 according to the parameters applicable to the bridge. The calculation can be performed according to several types of bridges and according to the types of bridges specified in the S6 bridge code. It also includes the statically determinate analysis type. That is to say, when the bridge consists of only two main longitudinal girder or trusses. Here we have an example of a slab on girder bridge category. We will specify an equivalent span length of 16 meters, and the number of lanes will be equal to 3. The width of the roadway will be 12 meters. It is assumed that we are analyzing the internal girder of the bridge versus the two outer girders. It has a total number of beams equal to 3 for the bridge. The girder spacing will be 5 meters. The distance of the cantilever between the outer beam and the edge is 1500 millimeters. And finally, DVE, distance of 2100 millimeters, which is measured between the edge of the bridge and the last axle of the truck when centered in its roadway. SAFI calculates various lateral distribution coefficients, called LDC, applying for various limit states, for bending ultimate limit state or fatigue, and shear ultimate limit state or fatigue. Depending on the type of analysis you want to perform, we will extract values, those required for the current analysis. Either it will be the values for the ultimate limit states or values for fatigue limit states. We just defined a unique lateral distribution coefficient for the entire bridge. However, it is also possible to specify a lateral distribution coefficient which will vary from one beam to another by adding a new tab. In this new tab, you can, for example, specify a different span length. For example, let's select an equivalent length of 18 meters. This gives a different bending lateral distribution coefficient for this tab. We can go ahead and rename the tab Span 2. For now, this lateral distribution coefficient will not be associated with the second span. That is to say, that for the moment, this new lateral distribution coefficient is not yet associated in the model. We can go ahead and run the moving load analysis. For example, one can go visualize the bending moment caused by the truck. We can then associate the different lateral distribution coefficient to the beam of the second span to note its influence on the bending moment curve. When editing the second member in the Bridge tab of the Member Attributes command, I can change the lateral distribution coefficient to the one that applies for this span. We will go ahead and run the analysis again. After the analysis, we can see that the bending moment curve has been updated. Since the lateral distribution coefficient is not the same for all the spans, we can notice a slight jump of the bending moment curve in negative moment over the central support. I hope you enjoyed this video. For more information, please visit our website at www.safi.com.